Okay, in this one we're looking at principles of data collection. Basically, we're talking a lot about surveying and surveying types. So some terms around surveying. We have population, which is just the entire group being studied. It could be everyone in terms of people. A lot of times we think of surveys as people, but it doesn't necessarily have to be people. It could be items. If you're in a light bulb factory, perhaps it's each of the different light bulbs that you're testing to ensure the lifespan of the light bulb, something like that. Sample is just the part of the population being selected. So if you wanted to find out the opinion of Canadians across the country, it's not really feasible to ask all 30-some million people their opinion, so you pick a sample of the population to survey to make it more realistic financially and time-wise. And that. Variability is an important concept. So it's how the samples differ from each other. So similar samples should have a lower variability. The lower variability means more accurate representation of the population. So if you take samples from different at different times and different people, you want them to be similar to each other so that there's less inconsistency in the types of people. If you were doing a survey about weight loss and you did a sample of the population who was generally considered overweight, and then you did a separate sample of people who were generally considered fit and well with or underweight even, they might not be comparable, and so there might be that variability, the change of their weights and lifestyles could have an effect on your results. When we're picking samples, we're looking for representative samples. So a representative sample is a sample that gives each member of the population equal chance of being selected. If a sample is not representative, it is unreliable and biased. It may not always be possible to give every single person an equal chance of being selected, and thus there might be some unreliability or bias within any sampling techniques that we do depending on the size or situation. But we often try our best to ensure that we try to be as representative of everybody as we can so that we can ensure a limited amount of bias and more reliable results in our sampling. Now, as to methods of taking samples slash surveys, things like that is another way to think of it, is to be straightforward, a simple random sample. And a simple random sample is just where we randomly choose a number of people from the population or number of items from the population, such as if we just pulled names out of a hat or out of a box. So if we put everybody's name in a box and drew them out, that would just be a simple random sample. Every one of those names has an equal chance of being selected out of the box, and it's one of the most straightforward methods of making a sample. Now, it might be more effective to try a systematic method. So a systematic method has us order the population in a list and pick at a random interval. So you might order everybody in the school in alphabetical order, print off a list of all the students in the school in alphabetical order, and then starting at the 4th person on the list, select every 10th person from there. So the 4th, the 14th, the 24th, and so on until you select a group of students to survey. And that would, again, be systematic. So you're creating a system of selecting people to choose a pretty equal chance of selecting everybody. However, there are cases where this could cause issue. Stratified samples divide the samples into groups of equal proportion to the proportions of the population. So if we were going to sample all the kids in the school, perhaps we select 10% of the students in each grade. So if we have grades 9, 10, 11, and 12, then we select 10% of the grade 9s, 10% of the grade 10s, 10% of the grade 11s, 10% of the grade 12s. It's equal to the proportion of students that are there. So that if there's more grade 9s, then they should get more representation. And so sometimes this might allow us to provide a more representative sample. And again, like any other method of sampling, it could include biases in that, so you need to make sure that you're selecting the best method of sampling. A cluster sample is when you divide the population into groups and then randomly select some of the groups to survey. So randomly selecting 2 McDonald's from each state or province in North America, and then surveying every employee at that McDonald's. So we take all the McDonald's in Ontario, all the McDonald's in Quebec, all the McDonald's in Ohio, and each state, province, the various provinces in Mexico, and we select 2 of those McDonald's and do a survey of every single employee in those McDonald's. That would allow us to divide the population up into groups based on provinces, and then get an opinion of those provinces. You can continually subdivide as well into smaller groups depending on what seems to make sense in the situation. And then in that case, we're kind of doing, it would be similar to what's called a multistage situation. So a multistage and a cluster sample are similar, where a multistage divides the population into a hierarchy of stages and randomly select some at each stage. So it's often a combination of stratified or random and simple sampling techniques. So if we divide all the students in Canada or Canadian elementary schools into the provinces, so we take each province and look at their elementary school students, and then in each province we only select some school boards. Maybe we select 3 of the school boards in each province, and then in each school board we select 3 schools, and then from each school we select some students. And so when we're doing these selections, they could, at each stage, so we've divided everything up into stages. Now we might be using some of the other methods like stratified, cluster, or simple sample techniques to select those boards or schools or students along the way. And then 2 that tend to throw in more bias than most would be the last 2 here: convenience sampling and voluntary sampling. Convenience sampling occurs when we select the most easy to access members of a population, such as just selecting the students that are entering the cafeteria. So if you want to sample the students in the school, you just select whoever walks into the cafeteria. This would be convenient and easy to access, but again could provide more bias because there's only a certain set of students that might access the cafeteria, or that might be factored in depending on what the survey is looking for. And then in terms of a voluntary survey, that's just selecting members of the population who choose to participate. So if you set up a booth and ask students to come and take a survey, they have to be willing to take their time to come do it. This could present issues like if it was, what are your thoughts on the upcoming presidential election? And you might get more people who are opinionated and have a very strong opinion about things to volunteer versus those who might not have a strong opinion but might outweigh those who have that strong opinion. So these last two are very prone to bias. However, they are some of the more effective ones to do in terms of getting quick results. So if we just look at some of these situations again, we'll look at situations and then try and decide if they're representative population, what the type of sample, and then if they're representative of the population. So first one, if you want to find out if your town is in favor of starting a composting pickup service, so you go and you walk up and down your street and you ask everyone, hey, are you guys in favor of this? This here would be considered a convenience sample. And it probably wouldn't be representative of the population, because if you look at any individual street or area of town, even locally, you'll see there's different income levels, so different social and economic factors that could play into that may make it non-representative. Second one, a university is pooling students. 200 students are selected in the same proportions as enrollment in each department. So we're looking at each department in the school, say math, science, history, geography, engineering, biology, chemistry, whatever the divisions specifically are. And then they're selecting 200 students proportionally from each of those sections. So in this case here, what we're looking at is a stratified sample because we're dividing the samples up into equal groups by proportion. So this is a stratified sample. This would likely be representative. Of the population, depending on how we explicitly choose the students in each section afterwards, it could cause effects depending on what we're researching. But in general, it should be representative. And the third one here, there are 139 swim clubs in Ontario. Swim Ontario, a governing body, conducts a survey to vote on its new logo. The organization randomly selects 10 clubs and surveys every member. So this type of situation here is selecting 10 of those clubs. So it's taking the clubs as individual groups and then randomly selecting from within those groups. So this would be a clustered sample. Would it be representative in this case? It depends on where those clubs are coming from. If they end up selecting a lot of Southern Ontario clubs and excluding Northern Ontario clubs or something like that. So this could be non-representative. So it just depends on the situation of as to what specific clubs are selected. So, but it could lead to that in this situation. Names are pulled out of a hat to win a lawnmower. So in this case here, we're just putting a bunch of names in a hat, drawing them out, and whoever gets their name pulled gets a lawnmower. This here is just a simple sample, simple random sample. And in this case, would it be representative of the population? Yeah, it would be. Everyone has an equal chance of being selected in that case. A couple more here. Questionnaire is sent to every 9th person on an alphabetical list of a store's customers. The first person is chosen randomly. So here we're random selecting, say maybe the 10th person on the list and then selecting every 9th person afterwards. This here is a systematic sample. It would likely be representative. Again, it could depend on the specific situation as to the questions, but in general should be representative. And then the second last here, student council invites all students to provide ideas of activities. So student council is looking for some activities, and they invite the students to provide ideas. So invite meaning if you want to provide something, so that would be voluntary. And this is generally non-representative of the population. It could be if everybody participated, but again, in general, most people are volunteering if they actually have a strong opinion about something. And then finally, a marketing firm wants to collect info on a product. In a city, they randomly select 10 neighborhoods. 5 streets are randomly selected from each neighborhood, and 10 houses are selected from each street. In this case here, we're looking at multiple stages happening. Multiple stage or multi-stage situation. And if they're selecting 10 neighborhoods from throughout the city, Each neighborhood would generally have different social economic backgrounds, and then the 5 streets selected randomly from each neighborhood and then 10 houses from each street should be representative of that population. So, simple, random, systematic, stratified, cluster, multi-stage, convenience, and voluntary sampling techniques are the various types of samples that we have. We want to, again, make sure we are trying to be conscientious of bias and representation of the entire population when we are calculating these surveys and doing surveying and collecting data.